Welcome to All Force e-learning session 9 here. Yesterday we have completed session 8. In session 8 we have discussed about the nature of living group, the nature of nucleophile. Now we will discuss about the nature of solvent. Nature of solvent means here SN1 is given, SN2 is given. Already you have discussed that concept in difference in between the unimolecular nucleophilic substitution reactions and bimolecular nucleophilic substitution reactions. So SN1 reaction is given, polar protic solvents are favorable here. Polar protic solvents are favorable like H2O, ROH or NH2 which are produce H plus ions. Nothing but somewhat ionization is important in this case. So unimolecular nucleophilic substitution reaction is given, polar protic solvents are favorable which can produce H plus ions. Wherever SN2 reaction is given, aprotic solvents are favorable. Aprotic means which does not produce H plus ion is generally called what? Aprotic solvents. So aprotic solvents are favorable here. Dimethyl sulfoxide, dimethyl N-dimethyl formamide, DMF, DMSO, dimethyl sulfoxide, dimethyl formamide. Here methyl cyanide compounds, acetone, nitro compounds which does not produce H plus ion is generally called what? Aprotic solvents. So aprotic solvents are favorable for SN2 reactions. Protic solvents are favorable for SN1 reactions here. So this one is nature of solvent. So factors affecting on nucleophilic substitution reactions, first one is nature of substrate, nature of living group, nature of nucleophile, nature of solvent here. So these are the factors. Next one is SNI reaction. SNI, intermolecular nucleophilic substitution reactions. Intramolecular nucleophilic substitution reactions. In intramolecular nucleophilic substitution reactions. I means intra or internal, N means nucleophile, S means substitution. Intramolecular nucleophilic substitution reactions. Intramolecular nucleophilic substitution reactions. What type of compounds undergoes intramolecular nucleophilic substitution reactions? Wherever SN1, SN2 is given, we can explain easily. Simple RS is given, undergoes bimolecular reactions. Wherever tertiary is given, undergoes unimolecular reactions. But intramolecular means outgoing group and incoming group present in the only one compound, nothing but intermediate type compound here. So alcohols undergoes intramolecular nucleophilic substitution reactions in the presence of SOCl2 or COCl2. Very few examples for intramolecular nucleophilic substitution reactions. So for example here alcohol is given which is having connectivity like this, here OH. The compound reacts with thionyl chloride SOCl2 or COCl2 in the presence of pyridine medium or absence of pyridine medium doesn't matter. OH minus is substituted by Cl. OH minus is substituted by Cl here. OH minus is substituted by Cl, SO2 plus HCl, hydrochloric acid. One of the best example for SNI reactions. SNI reactions. Retention product is important in intramolecular nucleophilic substitution reactions. For example, here given compound is given like this, which is having hydrogen, here R group, again R group, again OH group. The compound reacts with SOCl2. The compound reacts with SOCl2. First step is removal of HCl. First step is removal of HCl here. Removal of HCl. Form this type of compound, which is having two R groups, again S double bond O Cl. Sulfito compound, which is having S double bond O Cl compound is formed here. C double bond O Cl compound means here here oxygen S double bond O Cl here. Due to the presence of more electronegativity, which one? Oxygen. Oxygen electronegativity is more. The carbon and oxygen sigma bond electron migrate towards here. Oxygen means here bond cleavage is possible in between the carbon and oxygen. The sigma bond electron migrate towards oxygen and sulfur. New sigma bond is formed in between the oxygen and sulfur. After formation of bond, here bond cleavage is possible. The chlorine released as minus, nothing but with sigma bond electrons. The bond electron migrate towards carbon here. New sigma bond is formed in between the carbon and chlorine. Carbon and chlorine here. So new sigma bond is formed in between the carbon and chlorine. Carbon and chlorine here. Here hydrogen. Here bond cleavage is possible. Bond cleavage is possible in between the carbon and oxygen. Here bond formation is possible. Bond formation. Here bond cleavage is possible. Bond cleavage is possible in between the sulfur and chlorine. Here bond formation. Here bond formation. Here bond formation. Here bond cleavage. Here bond cleavage. Final step. Cl plus SO2. Cl plus SO2. So outgoing oxygen and incoming chlorine. So this type of reactions are generally called what? Intramolecular nucleophilic substitution reactions. Alcohols undergoes intramolecular nucleophilic substitution reactions in the presence of COCl2, carbon oxide dichloride, sulfur oxide dichloride. Form the final product. Retention product is important in this case. Retention product is important. For example, here compound is given like this, which is having methyl group C2H5. C2H5. Here OH is given. SOCl2 is given. SOCl2 is given. OH is replaced by Cl. OH is replaced by Cl here. Here CH3 is given C2H5 and HCl plus SOCl2 plus HCl. SOCl2 plus HCl. Already we have discussed about this reaction, preparation of alkyl halides from thionyl chloride. One of the best preparation method to prepare that chlorine compounds. Already we have discussed that one, but not iodine and bromides. This is the way to write that intramolecular nucleophilic substitution reactions. Now we will see examples on nucleophilic substitution reactions. Given reactant undergoes SN1 reaction or SN2 reaction, how can you identify? Means based on the given substrate, or when you write that mechanism, we can identify easily what type of mechanism involved in this process. Bimolecular mechanism or unimolecular mechanism. For example, here given compound is given like this. Given compound is here CH3 is given, here H is given, here CH3 is given. CH3 is given. So 2-chloro-2-methyl propane compound. 2-chloro-2-methyl propane compound is given. 2-chloro-2-methyl propane compound reacts with aqueous NaOH. Remember, alcoholic medium is given, elimination takes place. Wherever aqueous NaOH or KOH is given, substitution is possible here. The Cl minus is substituted by OH minus. But that given substrate has what type of connectivity? What type of connectivity here? 1, 2, 3. Tertiary alkyl halide. Tertiary alkyl chloride. Wherever tertiary is given, what type of mechanism is possible here? Unimolecular mechanism. So here CH3 is given, again CH3, CH3 again OH. The Cl minus is substituted by OH minus. 2-methyl 2-hydroxypropane is formed in this case. Propane is formed here. Given compound is not carrying any type of chiral center. That's why no chance to get the racemic mixture. Given compound means substrate or reactant. The reactant is not carrying any chiral center. Due to that reason, we'll get only one product. Only one product here. CH3O like this. For example, here compound is given like this. Here CH3, again CH3 is given, again CH2Cl is given. CH2Cl is given. Given substrate nature is primary nature. Given substrate nature is primary nature. Primary alkyl halide. Primary alkyl halide. Primary alkyl halide is given, but given compound is tertiary compound. Given compound is tertiary compound here. So here first step is bond cleavage step. Cl minus here. Cl minus here. Here CH3 is given, again CH3 is given, again CH2 plus. CH2 plus. Formed carbocation is primary carbocation, but that adjacent carbon has tertiary nature. Now hydride shift is possible in between the tertiary carbon and primary carbon. Carbocation rearrangement is possible here. Carbocation rearrangement is possible here. Here CH3 is given, again CH3, again CH3 plus here. Again CH3 plus. So next step is nucleophile attacking step. Next step is nucleophile attacking step here. Again form the CH3, again CH3 OH. Or if you write like this, both are same in this case. Both are same here because no chiral center here. This is the way to write that rearrangement product. Rearrangement product here. Rearrangement. For example, here CH3 is given, CH3 is given, again CH2 is given, CH2 is given, again CH2Cl is given, or Br is given, or I is given. The compound reacts with OH minus, nothing but aqueous NaOH or aqueous KOH is given. Nucleophilic substitution is possible here. Given compound is primary. Given compound is primary means then follow that SN2 mechanism. But according to the structure, the molecule undergoes unimolecular nucleophilic substitution reaction due to steric hindrance. The incoming nucleophile will attack that substrate only back side or front side, means based on the mechanism we can explain. Due to steric hindrance, SN2 is not possible in this case. Maybe SN1 is possible. When you write the mechanism, we can get answer in this case. So nucleophile attacking step somewhat difficult, presence of steric hindrance. That's why the given molecule follow that SN1 mechanism. Here also same thing. First step is slow step. Rate determining step here, bond cleavage step. Bond cleavage step in between the carbon and chlorine compound. Now here CH3 is given. Again CH2H is given. Here CH2 plus. The formed intermediate is primary carbocation. But that adjacent carbon is having secondary nature. Hydrate shift from secondary carbon to primary carbon in this case. So carbocation rearrangement is possible here. So Wagner-Mervian rearrangement. Less stable carbocation convert into more stable carbocation in this case. So hydrate shift from where to where? Secondary carbon to primary carbon. Now the positive charge migrate towards secondary carbon. The positive charge migrate towards secondary carbon here. So here CH3 again, CH3 again, CH3 here, CH plus here, CH3 secondary carbon here, secondary carbon. Again the adjacent carbon is having tertiary nature. One more step is important in this case. One more step is possible. Reason, tertiary carbocation is more stable when compared to secondary. Now hydrate migrate towards tertiary carbon to secondary carbon. Hydrate migrate towards what? Secondary carbon here place. So formed carbocation is tertiary carbocation. So more stable carbocation is formed. Final step is nucleophile attacking step. If you take OH minus means the OH minus is added to where? C plus. Final product is CH3 again CH3 OH again CH2 CH3. 2-hydroxy 2-methyl butane is formed. Given substrate having primary nature, but even though having primary, the molecules follow that SN1 mechanism due to the presence of rearrangement here. Due to bulky nature, the incoming nucleophile attacking somewhat difficult. According to that concept, the molecule follow that SN1 mechanism. Here also same thing, due to absence of chirality or chiral carbon, no chance to get the racemization or racemic mixture. So we cannot get a racemic mixture in this concept. This is the way. Wherever compound is given, primary compounds having primary alkyl halide or secondary alkyl halide or tertiary alkyl halide doesn't matter. Based on the rearrangement, we can write the mechanism in this case. So given substrate, based on the given substrate, we can explain that concept. For example, here simple alkyl halide is given, methyl chloride or methyl bromide or methyl iodide compound. The compound reacts with silver hydroxide, OH group. Silver hydroxide is given. Nothing but one type of hydrolysis reaction. Ag plus and OH minus. OH minus is nucleophile in this case. Incoming nucleophile OH minus, outgoing nucleophile Cl here. So Cl minus is substituted by incoming OH. Final product is methyl alcohol. Final product is methyl alcohol here. Methyl alcohol here. Wherever dry silver oxide is given, moisture silver oxide is given means the moisture silver oxide in the presence of nothing but moisture, the compound convert into silver hydroxide. So due to that reason we will get hydroxy compound. Wherever dry silver oxide is given, dry silver oxide is given, Ag2O is given. You remember, dry condition is given, alkyl halides form the ethers. Here CH3O or CH3. 2 moles alkyl halide is required in this case. Dry silver oxide is given means we will get ethers. Moisture silver oxide or directly silver oxide is given, we will get with alcohols, nothing but nucleophilic substitution reactions. Nucleophilic substitution reactions. For example, here the compound reacts with NaOH. The compound reacts with NaOH. The compound reacts with KOH. KOH. What will happen in this case? Again, the molecule undergoes nucleophilic substitution reactions. The Cl minus is substituted by OH minus. So methyl alcohol is formed in this case. Methyl alcohol is formed here. For example, here Na sodium methoxide is given. Given reagent is sodium methoxide, which is a nucleophile CH3O minus Na plus. CH3O minus, the Cl minus is substituted by OCH3 minus. CH3 here, OCH3 here. Ether is formed in this case. Ether. For example, here sodium ethoxide is given, C2H5. C2H5. Sodium ethoxide is given. Ethoxide anion is nucleophile. Cl minus is nucleophile. The Cl minus is substituted by ethoxide anion. That means here CH3O C2H5. So one type of preparations, one type of ethers preparation. So alkyl halide compounds reacts with the alkoxides, sodium alkoxide or potassium alkoxide form the ethers. Alkyl halides reacts with the alkoxides, sodium alkoxide, potassium alkoxides form the ethers. Is generally called Williamson synthesis. Williamson synthesis of ethers. Williamson synthesis of ethers. We'll discuss about these reactions again in ethers chapter, preparation of ethers. So deeply we will discuss that concept later. So, but what type of reaction? Nucleophilic substitution reaction. Nucleophile is substituted by incoming nucleophile. This one is leaving group, this one is incoming group. So final product is Williamson synthesis. For example, here NaCN is given. Which is nucleophile here? Cn minus is nucleophile. Which is nucleophile here? Cl minus is nucleophile. So final product is cyano product. Cl minus is substituted by Cn minus. Methyl cyanide is formed in this case. For example, here sodium azide is given, NaN3. NaN3, Na plus, N3 minus. N3 minus is azide anion, Cl minus is nucleophile here. That means final product is CH3N3. CH3N3 here. For example, here CH3COO Na is given. Sodium acetic acid is given in this case, which is nucleophile CH3COO minus, Cl minus. Here CH3, again new bond is formed in between the oxygen and the carbon, O, C double bond O, CH3. Formation of esters. Formation of esters. Acid salts reacts with the alkyl halides form the esters. So given reactant is primary. Given reactant is primary. All these reactions are substitution reactions. What type of substitution? Nucleophile. One nucleophile is substituted by incoming nucleophile. But primary means all these are SN2 reactions. All these are SN2 reactions. So based on the substrate or reactant, we can explain what type of mechanism is possible here. For example, here CH3 is given, here CH2, Cl or X is given. X is given. X is called chlorine or bromine in this case. Chlorine or bromine. So ethyl chloride is given, ethyl bromide is given, doesn't matter in this case. Again compound reacts with moisture silver oxide. So silver oxide is given, moisture silver oxide is given, silver or hydroxide is given. Silver hydroxide is given, KOH is given, KOH is given, KOH is given, NaOH is given, NaOH is given, RCOO, Na is given, NaN3 is given, NaN3 is given. So first to find out the what type of nucleophile is present in given reagents. OH minus is nucleophile, OH minus is nucleophile, OH minus is nucleophile, RCO minus is nucleophile, N3 minus is nucleophile. Given reactant is having what? X, chlorine or bromine or iodine. X minus is substituted by incoming nucleophiles. So final one is CH3 again, CH2, OH. Again CH3 here, CH2, OH. One type of hydrolysis reactions here, OH. Again CH3, again CH2, which is nucleophile here, or COO is a nucleophile in this case. Again ester is formed. Why? Because this one is carrying RC11OR, RC11OR, which is nucleophile here. Azide ion is nucleophile. N3 minus. This is the way to write that products from given substrate. But here secondary alkyl halide is given. Primary alkyl halide is given. Primary alkyl halide is given means there is nothing about mechanism. Why? Because simple compounds means the simple compounds undergoes SN2 reactions. SN2 reactions. If simple compound has chiral center, will get Valence inversion product. If there is no chiral center means simple inversion product we have to write in these cases. This is the way to write that compounds are given reactions. Based on the given reactant and reagents, we can identify what type of mechanism is possible in between the two. So simple compounds are given. Simple compounds means majority of the compounds undergoes bimolecular nucleophilic substitution reactions. So thank you.